Hello, folks. Welcome to Rational Science. We got a busy day today, so I'm just going to get right into it. I'm going to start with a couple quotes. One is by Euripides. He was a Greek playwright, okay? And this is what he had to say, which I think is pertinent today for what we're going to be talking about. It says, if you bring novel wisdom to fools, you will be regarded as useless, not wise. And if mathematical physics regards you as greater than those with a reputation for cleverness, you will be dismissed as a crank. Not the exact words that Euripides pronounced, but I think that's pretty close. And a few hundred years later, we have this fellow, his name is Galileo, and he said something similar. He says, in time you may discover everything that can be discovered, and still your progress will only be progress away from humanity. That's interesting. The distance between you and them can one day become so great that your joyous cry over some new gain could be answered by a universal shriek of horror. Yeah, I feel for them. I know what they felt because, I felt it in my own skin. And, I have a different saying that I like to use out there, and that's this one. Can't beat them, ridicule them. So that's what I do. I try to ridicule these people because they are ridiculous. Their ideas, the explanations they have for how this universe runs at the microscopic level, at the universal level, and we're talking about not only general relativity and quantum mechanics, but you're talking about string theory as well, which is trying to merge the two. It's unmergeable, and they never discovered that, but someday maybe they will. Who knows? Anyways, you say, well, Bill, why should you ridicule them? Shouldn't you treat them nicely? Don't they deserve some respect? Well, again, when I came out with my theory, I was surprised. I thought the world out there was scientific, and I had this notion that, in science you present your ideas, people listen, say, well, I don't like your idea. That's fine, no problem. But when you're not even allowed to present your idea, when you have a different idea, right? And on top of that, they throw rotten tomatoes in your face. Well, then at some point, a lot of people start rebelling against that. And you might say, well, should I be wearing a tin cap over my head or whatever? No, it's not an issue of that. It's that, people have always criticized those with different ideas. And once you have a clique, a group of people, a clique, that take over, they can censor all those people that don't agree with them. So now you have an established religion because now new ideas can't get in there. And that's the status quo today. But see, if you go back to the days of the Greeks as well, you'll find that all these schools, they did the same thing. They threw caca at each other's faces. They treated the other guy, they would laugh at him and say, look at what this guy believes in, and so on. So, we've got a long history in so-called science where instead of being polite, being civilized, and people are allowed to present their theories without any objections, especially if they have a new theory. I don't even care if it's a flat earther. I don't really care. I don't agree with flat earthers. I don't agree with the electric universe, etherists, or any of those people. But, I think they should be allowed to present their theories and that you should be allowed to criticize them. And you say, well, but they have all these crank theories, all these idiotic theories. Well, what does quantum mechanics have? They have bigger idiocy still. Well, what does quantum mechanics, what does general relativity have to offer? Just ridiculous garbage. Okay, what do you see today in general relativity? Well, you'll see black holes, dark matter, dark energy, Big Bang, other universes, parallel universes. You see only garbage, just garbage. All of that can be thrown totally in the trash can. None of it survives science. And likewise, in quantum mechanics, you have all these weird notions, that a particle can be at two places at once, that this particle can affect that one without any mediator, between them, physical mediator between them, that you have superposition, you have particles coming from the past, from the future, like tachyons and so on, faster than light, which violates special relativity, but they live with both stories anyways. They say, oh, but we like tachyons because that allows us to get off the planet someday and go to the nearest star. Who knows why? But they allow all these theories, but they don't allow flat earthers, they don't allow ethers, they don't allow, the plasmoids. They should allow all of them. I mean, if we're going to tolerate the garbage of quantum mechanics, we might as well, tolerate them all. And it turns out that there's this fellow, and his name is Jacob Barandis. I think that's how you pronounce his name, Barandis or Barandis, something like that. Anyways, he's from Harvard, and I think they're grooming him to be the next Carl Sagan or something along those lines. Like the next celebrity for the new generation. The older generation passes by, like Carl Sagan. You don't hear as much also about people like Brian Greene. And now you need the new guys. The new guys have been brainwashed in all these colleges, right? All these universities. And now they get to carry the baton, right, to the next generation. And some of these guys, you have like Hassenfelder and you have Penrose and all these people. And, people say, oh, I like this guy because he's kind of like a dissident. No, none of them are dissident. They were all brainwashed the same garbage. They all believe in quantum mechanics. They all believe in relativity. And within that, they say, well, I'm more like a wave guy. And the other guy say, well, I'm more like a particle guy. And so they get into fights about, petty stuff that has nothing to do with anything. There's no differences between any celebrities. A guy like Neil Tyson believes exactly the same garbage as Brian Cox, as Brian Greene, as they all believe in the same nonsense. There is no difference between them because they all accepted, first of all, the quantum atom, which is the planetary atom, and that's the one they use, or the one they've been led to believe is the one that got to be used for ionization and for electricity. That's the one they use, that model. And then they say, well, that's not our model. That's not the real atom. That's, So why did they present that atom of, the planetary atom, the orbiting bead, if that's the one they're going to be using to do their presentation for ionization, electricity, and all this stuff, and quantum jump and so on. So yeah, we have a problem because these people have hogged, the reins of science, you could say, physics, and which is nothing related to science or physics, but they're the people who control what reaches the public, right? And they're the gate, the gatekeepers. Okay, so we have this Jake Barandis, okay, and who is he? Well, he's some kind of philosopher of physics, physical philosopher. They've got all these billions of categories in mathematical physics that, I don't know why they had to create all these categories. In physics, in general, in science, in real physics, in genuine physics, it's just physics and philosophy. And those are the two branches of science. That's it. There's no more. And within that, you could break it up in a little more, a few more categories, like paleontology or biology or whatever. But the main two categories are physics and philosophy. Never the twain shall meet. And this fellow says that they do meet. He says the following: says, I do research at the intersection of philosophy and physics. My work has two sides, and he mentions two sides. He says physical philosophy and philosophical physics, whatever nonsense that is. I don't know what he's talking about when he creates these categories. Maybe to make more money. I don't know. And so the question is whether this guy has any knowledge of physics or philosophy. And so what is physical philosophy? It says involves examining what our most successful physical theories tell us about traditional questions in metaphysics and the philosophy of science. I have no idea what this metaphysics is, what philosophy of science is. In real science, in genuine science, there's only physics and philosophy. Okay, there's no such thing as metaphysics or ontology or semantics or philosophy of science. And then you have this other side, is philosophy of philosophical physics. What is that? It involves using the methodological tools of analytic philosophy to what? Make progress on open problems in physics. Why do we need the word philosophy in there? If you want problems in physics, it's called physics. That's what we solve. We solve problems in physics. And what is physics? Well, you got to explain how this universe works. That's what it is. So in general and genuine science, we only have these two categories. That's it. Science, rational explanations. What are the two branches? One is the rational explanations of causes and mechanisms, and philosophy is the rational explanations of reasons and purposes. We're done. Okay? Scientist is a guy who presents to a crowd and tells them a theory. He explains something. Right? He doesn't describe mathematically. He doesn't do an experiment in front of them. He explains. That's the scientist. Anybody can do an experiment and not understand squat about what he's doing, which was the case of Michael Faraday. He just did experiments. He didn't know what he was doing. Okay, so this fellow, he's a philosophical whatever, physicist or physical philosopher or whatever. Okay, and I like the fact that he says he works on the foundations. I thought he was going to say of physics, but he does say that, like you can say foundations of physics on the left, but he says he works primarily on quantum mechanics and the metaphysics of causation, which is very interesting because I work on the physics of causation. It's very close to what he does. Okay, but what's the problem with this guy? If he's a physicist, he's a philosopher, hey, better yet, he's got two branches of science. He knows about objects and he knows about people, right? He knows how people behave, etc., or whatever he understands by those two words. Anyways, the point is that I don't care what field he's in. He could be in just strictly physics, or he could be in philosophy according to what he thinks philosophy is. And remember, the Stanford Encyclopedia of Philosophy never defined the word philosophy. Nobody knows what philosophy is. Nobody has defined what physics is. Nobody has defined what science is in a scientific manner. And so we don't have definition for these three words. So, we're going to be running around in circles with people like this Barrondas. Anyways, you would think that if he's a physicist, right, and he's also a philosopher, I don't care which base he touches, the word he should be able to define is the word exist. The word real. What does real mean? What is exist? I mean, you would think that that's the first word he's got to learn. I mean, we learned it in the first day of class in physics, in science, right? And he says he's a physicist, warmed the seat for 10 years. He at least has to know what exist means or what real means, right? And here's from the horse's mouth. You can hear it from him directly. Okay, this is what he's got to say. Listen to him carefully on how much he knows about what real is and what exists is.
I don't have a definition of what real means that doesn't involve words that essentially mean the same thing as real. To say something is real is to say that it exists. But what does exist mean? To say that it is real, really there. Some very primordial, primitive notions can be very difficult to define rigorously in a way that isn't logically circular. So for these kinds of notions, and these include things like reality and existence, they are very difficult to define.
Okay, so does this fellow know what exist means, what a real means, what actuality means, reality? I mean, you would think that as a minimum, he should learn that word. He should know what it is. Why? Because physics is the science of existence. Here it is. Physics is the science of existence. He who cannot define the word exists is neither physicist nor philosopher. Okay, so this fellow is neither one of those two. The job of a physicist has always been to tell the audience what exists in the universe and how it works, meaning why it works, right? What causes it to work the way it does, the mechanism. That's what we're interested in. Yet not a single philosopher, physicist, researcher, theologian, or theorist in the last 10,000 years has ever been able to zero in on a definition of strategic word exist. And this is strange because, they had all this time. You got all these philosophers and physicists, and they've been talking for years, for hundreds of years, and not one of them can define the word exist in a way, like he said, where it's circular, where all you have is synonyms. And he says, so difficult to define. But what's interesting, he's never figured out, as a so-called physicist, so-called philosopher, that this word is so important, and yet nobody has defined it in 10,000 years. It never clicked in his mind that something must be wrong. And so, yeah, you have, not a single textbook of physics, which is the science of existence, right, begins by defining the formidable word exist. And this explains why atheists, theists, and agnostics debate in circles about the existence of God. All of them just use synonyms. And here you see it, atheists, theists, and agnostics argue in circles. Why? Because they never defined the word exist. Not a single one of them knows what exist means, what real means. And yet, again, physics is the science of existence, and unless you define that, you won't know if God exists. You want to know if God exists? Very simple. Define the word exist. That's how simple it is. And what they use all these synonyms that you see at the bottom there, real, reality, actual, actuality, and so on. And you can't use synonyms to define a word because synonym is a circular definition, otherwise known as no definition at all. That's what a synonym is. So you can't use synonyms to define. And these people begin talking. I mean, this guy talks for hours on YouTube, on the internet. Talks for hours about the existence of that, he uses that word constantly. He wants to know what's real out there. He wants to know how this universe works. And he had never defined the word exist, which is absolutely ridiculous, right? Okay, so this is what we have to say to a fellow like him. And this comes not from me, okay, but a fellow over there in our Rational Science group in Facebook. And he says, don't whine, define. My friend Jeff has that saying, and I stole it from him. I hope he doesn't sue me for plagiarism. Anyways, this fellow doesn't know what exist means. He should not be crying. He should not be whining. He should be defining. And he probably would never, I don't think he has the brains to be able to define any word, let alone the word exist. I mean, and, there are more important words which we have in what we call the foundations of physics, what he says he's an expert at. Foundations of physics. You can't define a word like exist. Okay, so here we have the definition of exist. Okay, there you go. Exist, physical presence. Okay, it's an object that has location. And before you can talk about an object having location, you obviously need to define the word object and the word location. We're not going to define location today, but we do want to quickly say what an object is. And again, that's the other word that no one has ever defined, and not a single textbook of physics begins by defining the word object, and physics cannot be done without objects. So I like to say the definition of the word object destroys all religions. God, you believe in God? Does he exist? Very simple. First of all, we need to know if God is a physical object or is an abstract concept. Who do you pray to? Do you pray to this guy with a magic wand who made the universe? And is made in our image, by the way, so we have a pretty good idea that he's, looks like us more or less. Doesn't look like a cow or like an insect, right? He looks like us. And that's one version of God. The other version is the abstract concept. I mean, is he a spirit? Is he intelligence? Is he love? What is God? Is a concept that you pray to love? That's what's going to get you back into heaven, right? I mean, what is God? First, you got to determine that. And then if you want to know if he exists, well, he's got to have location. So if he's an object, right? If he's a concept, forget it. He can't exist. No concepts are said to exist in physics. And exist is completely dominated by the discipline known as physics. Physics has an exclusive property over the word exist. Nobody else can use it. No philosopher, no historian, no one else can use the word physics, exist. Only a physicist. That belongs exclusively to physics. Okay, so here's the definition of object. What is an object? Object, that which has shape. The only universal property of all objects. An object is not that which you can see. An object is not that which you can touch. An object is that which has shape. An object is not that which is made out of matter. None of those definitions are rational. They're all irrational definitions. I've talked about that in the past. Won't go over that. So this fellow who does Baranda's, he does foundations of physics, and let's see if they match foundations of physics that we have here. Okay, these are the foundations of physics. Now, which are the definitions you need to do physics. These are the cornerstones, the foundations, right? And we start with the golden principle of physics. Physics requires an object. You just can't do physics without an object. A lot of these people want to do physics with concepts. They have concepts such as field and energy flying around, mass, and they bend time and so on. No, we don't do any of that in physics. Okay, in physics, you have to have an object if you're going to give a physical interpretation, which is what physics is all about. Okay, and so physics requires an object. That's the golden principle. You can't. That's a non-negotiable principle, I'd like to say. What are the words you need to define? The first word is the word object. You need to know what an object is in physics. Not a single textbook of physics on planet Earth ever define the word object. And you can test me, look it up. Okay, see if you find one book and show it to me where someone said an object is blah, 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 right? Space, that which doesn't have shape. Distance, location, there you see it's a set of distances, and in order to define exist, you need the word object and the word location. It's an object that has location. And then you have motion and a concept, right? So those are the foundations of physics, okay? You need to absolutely define those terms if you're going to do physics, which is all about physical interpretations, about explaining how our universe works, meaning what exists first, and then explaining how it moves. Okay, so what were the problem with this fellow? Well, this fellow, he studied so-called physics, mathematical physics at a university. I think he studied in Harvard. And what was he taught? What did he learn? I mean, and, the main problem with what these people learn, which they learn by rote and never question, is that, light is mediated by particles or waves, subject that we're going to be talking about today. And it never occurred to him, never even crossed his mind to throw away the baby together with the wash water, erase the entire board completely and start all over again. It never occurred to him. He said, oh no, quantum we have to respect because it comes from Niels Bohr. We have to respect relativity, it comes from Einstein. We have to, pay homage to all these people, right? And so he never even questioned any of that. And still to this day, he doesn't question it. That's the issue. And here it is, okay? What they've been taught is that light is some kind of wave. It comes from all these bozos that we had in the 19th and 20th century. And we're saying that none of them hit it on the nose. What they've been looking at for the last 400 years, at least since the days of Robert Hooke, who came up with a wave notion in 1665 in his book Micrographia. He's the first guy that had noticed that there were that light had wave properties. And it never occurred to them that none of these words that they're proposing, like wave, whether it's transverse wave or longitudinal wave, is not a physical object. Wave is not an object. It's a mathematical concept. It never clicked on them in their minds. So they've been working with this thing, and they put it in motion, as you can see it there. And it also travels one way, in one direction. The rope, which is what what they've been looking at really in all these years, a rope that twirls in situ, not only shows you why light is so fast, because torsion is, leaves waves in the dust, biting the dust. Torsion travels very fast, along a rope. Why? Because it's already connected at the other end. Okay, and so all atoms in the universe are physically connected by a rope-like, DNA-like pair of twined threads. Okay, and the torsion of that is what we call light. That's how simple it was all these years. But these people are still, dealing with waves, which are mathematical concepts. Because what is a wave? What is it made out of? Well, it's made out of two fields, right? What is a field? Bunch of numbers in space. That's what they say. It's a value at each point in space. And what is a field made out of? It's made out of vectors. What is a vector? Magnitude and direction. Again, we have The wave is made out of numbers, which are made out of numbers. That's all we have, just a bunch of numbers. And so, yeah, here you can see synthesis of that. The electromagnetic wave has no chance whatsoever in science. We replace it with a rope, with a physical entity. Now we can do a physical interpretation, right? And one of the first things that you can explain right off the bat is why the velocity of light is a constant anywhere between any two atoms, anywhere in the universe, irrespective of the material, the density of the material light goes through. Let me repeat that because some people may not have heard. It doesn't matter what material it goes through. This notion that the mathematician created known as refractive index. I worked with that many years, at AMD when I made wafers. Refractive index is a mathematical concept where they look at the angle. They change the angle of light because they say, okay, when it goes through glass, like SiO2, light hits glass, it turns a corner. It bends, or really it deviates, which should be the correct wording that they should use, because if they're going to be using photons, discrete photons, and even if they use waves, you're talking about deviation. You're not talking about bending. What's bent is the brains between their ears. That's what's bending. They're talking about deflecting. That's what they're talking about. And so, because again, it's one-way travel. And so you're talking about deflection, not about bending, like they say. But with the rope, you can see why. If every atom is connected to every other atom, from one atom to the other atom, it doesn't matter where it is in the universe, what material it belongs to, the torsion of light between those two atoms is always going to be 300,000 kilometers per second. That's it, period. Why? Because C equals frequency times wavelength. Frequency goes up, wavelength has to go down, and vice versa. And there you can see it in a rope. You torque a rope, you make more links, and each link is shorter. You untorque the rope, now each link is longer, and you have fewer links. And that's what that equation is. That is the equation of a rope, not of a wave or whatever, transverse wave or whatever they call it, over there in mathematical physics. So yeah, at least we can explain that. That's one issue that the rope model can explain, which the wave of mathematical physics cannot. And it never occurred to bean brains such as Maxwell that they were dealing with concepts and not with objects, with physical objects. Physics is about physical objects, not about math. It has nothing to do with math. Math has no place in physics because physics is about explaining. Math can only describe, has no power to explain. An equation cannot explain anything, and it cannot tell you what exists out there. For that, you got to use your brain, especially for invisible, intangible stuff out there. Okay, and the other big error is this planetary atom that Niels Bohr and Rutherford came up with, which is a ridiculous thing. Why? Because you have this little bead, the electron, the blue one there. It's negative. We don't know what negative means. We don't know what positive means. But they say negative attracts positive and vice versa. The center of that atom is supposedly positive, the nucleus. And the question is, why doesn't the electron bead fall all the way to the nucleus, the positive nucleus? And that's one problem. The other problem is, why doesn't it spontaneously fly away? Why does it keep falling between energy levels? What is it? The energy level or orbitals, right? And they never explain that. Even to this day, we don't have an explanation from the quantum mechanics of why the electron doesn't fall. In other words, the physical reason. They start going into math. They say, well, you have so much potential here. No. Tell me what wall is there. I need to see the wall that prevents the electron from falling all the way to the nucleus. Likewise, I need to see the wall, whatever wall or whatever object you present. Physics is done with objects, right? You got to tell me what object prevents the electron bead from flying away. Okay, and then you have electricity. What is it? Or ionization? In fact, ionization is electron just comes out of there. Why? Why did it come out before it was ionized? Why does this electron bead flow from atom to atom and create this so-called electricity that they teach you in high school and college? And we have no answers to any of those questions. So we don't have physical interpretation. What we have is a bunch of math, descriptions, of an invisible world that they imagine being mediated by particles, by discrete particles. And what we need to abandon is the discrete particle together with a wave, throw them both in the trash can. Throw the baby away together with a wash water. None of that survives science, logic, or rationality. Okay, so here we have our atom compared to their atom. That's our atom, the rope atom, right? All the ropes converge on our atom. One thread goes to the center, the other thread goes around, builds the electron shell, membrane, or balloon, however you want to see it. It's a ball. It's a ball of yarn. That's what it is. And one thread goes through the center, and that's the proton star, as we call it. So we have a star which is encapsulated within a membrane. These are physical objects. The garbage you see on the left is a mathematical poppycock nonsense, whatever that is, but that's the one that they use even to this day. Okay, so yeah, their version of the atom has no place in science. Okay, and one of the things we can explain with our good old atom is another issue that Einstein was working with, and that's why the speed of light is not added to the speed of the source. You're running around with your car, you turn your headlights on. Do you add the speed of the car to the speed of your light coming out of your headlights? And the answer is no. Light always travels at the same speed, irrespective of the speed of the source. And here you can see why. Because the atom is torquing the rope that's between these two atoms as it slides, as it eats into the threads that go and make up that atom. So you can see the threads moving around and through the atom as it moves through. So it doesn't. So the rope does not have to move. In other words, it's constantly torquing, and the atom is just sliding through it like beads on an abacus. That's all it is. That's why you don't add the speed of the atom to the speed of light. They're two separate entities, and it's like it eats into the two threads that make up the atom. That's the way it works. And so now we can see why light travels so fast. Something that the mathematicians cannot explain. They cannot explain the cause, right? We can explain the cause. The other one we can explain, in other words, C equals frequency times wavelength, the inverse relation between frequency and wavelength. And the other thing that we can explain is why the speed of the source is not added to the speed of light. Okay? So we do have some explanations. Do you believe in the theory? Do you believe in my theory? We don't care. Belief belongs to religion. Here we come, we explain, you take it home, you do whatever you want with it. You don't want to believe, no problem. But here what we do is explain. We don't do like the mathematicians do. They say, we've proven. Give me a Nobel because I proved it. No, you don't prove. Prove means you convince someone. That's all proof means. Evidence, verification, all that just means you convince someone. That's got to do with belief. In science, we do not believe. In science, we explain so that someone understands the theory, and then everybody goes home or to their church, and that's when they start believing or disbelieving. Okay, let's move on to another subject. I had a couple of etherists. They came over, and there's several of them really that came over, and they started pushing their ether theory. And what can I say? Ether is, they have mental problems. And so I like to illustrate it like this again. I like to ridicule these people. They deserve to be ridiculed for their ideas. And so I don't fall back behind. Because, see, they come here and they come here and ridicule me. And but then they don't want to be ridiculed in response, and it doesn't work that way. It works both ways. So you should get that off your system. You're going to be ridiculed in the science, so-called science, by everybody. Everybody ridicules everybody else. Just accept it. Don't worry about it. Drop it. Never touch the subject again. So don't tell me that, Bill, you're insulting me. No, I don't insult anyone. I treat them with the respect that they deserve. Okay, that's the way I see it. Okay, so here we have it, and we had this gentleman. He was a paleontologist, 19th century, and he came up with an idea after seeing one of these big dinosaurs, right, long necks, and he said that came up with this second brain theory. Marsh noticed that the neural canal in the sacral region near the hips Stegosaurus was significantly larger than the brain cavity in the skull, because these animals apparently, for their size, had a very small brain in their skull, right? He initially theorized that this larger canal might house a second brain that helped coordinate the dinosaurs' hindquarters. And he later on dropped that theory, but, I think I'm going to revive it, at least for etherists, right? Because I think they're thinking with their butt brains. That's the one they have in their heads. And the other one, I don't know what they use for. Maybe for pooping. I have no idea, because they don't seem to be using their brains at all. And they can't understand simple concepts. So, what can I say? I think these people have mental problems. That's what I think it is. They don't have no reasoning capabilities. Okay, so one of the etherists, I gave him a challenge. I said, I need for you to define these words, because if we're going to have a communication, at least I need to know what he means by these words when he's pronouncing them, when he's mentioning them, right? And for me, these are critical words, and again, they form the foundations of physics, okay? And so I asked him to define them. He came up with all these, right? And you can see the dark ones there. I'm just going to look at those dark ones. I'll just synthesize that, take them out of there, and put them one right next to the other like this. Okay, so there you can see how he defined these words. And so we look at the first one. He said, I asked him what was the ether, and he said it's a medium. It's a continuous fluid. Okay, nothing is outside the ether. He says, it's like everything is the ether, right? Everything in the universe, and so. It's kind of weird, because he's saying it's a medium, which is a physical object according to us. He's got to define the word medium otherwise, because a thing, a medium, an entity, there you see all these synonyms that I wrote in green there on the right. And all these words mean exactly the same thing in physics. If he thinks an object is something different than a medium or a thing, then he's got to specify what he means by medium. Okay. Anyways, he said it's a medium, okay, and he says it's a fluid, it's continuous. I don't know what he means by continuous, because, again, I pointed out to him that Aristotle said continuous is that which can be chopped up into parts. His notion of Aristotle's, right, notion of continuity was the number line, that, you can chop a number into pieces. Okay, and that was a notion of continuity of Aristotle. And that's the one that a lot of mathematicians use today. His notion, this fellow's notion, is that continuous means that it's made out of a single piece, physically made of a single piece. That's what I told him to use, because then we can understand each other. So either it's segmented or continuous. Continuous means only that's made out of a single piece. But we have a fluid that's made out of a single piece. Okay, that's already kind of weird, right? Fluids usually, right, are made out of parts. But I can concede that, no problem. Fluid that moves around, but it's not made of parts. Think of it a rubber band, but it's made out of a single piece, right? But it's flexible. It's got the power to be flexible. No problem. But see, in order to see it, I need to see this medium, this thing he calls ether. Because he says he can't draw it, can't imagine it, he'd never seen it. And I'm saying, I don't care what the real ether looks like out there, Mother Nature's ether. I want to know the one you have in your head, the one you're going to use to do your physical interpretation. What are you going to put on the board? That's what I want to know, when you give your presentation. And, if you're going to talk about the ether doing this and doing that, and doing electricity, doing light, whatever it does, you better put something on the board. You better draw something. I don't want to see equations. I don't want explanations. I want to see a picture. I want to see a drawing. I want to see a snapshot, whatever. I need to see an image on the blackboard. Okay, so he couldn't pass that one. He has asked this. Really, I've been asking ethers for the last 30 years for a picture. No one can draw the ether. Nobody can tell you what the ether is. And you can go back all the way to the 19th and 18th and 17th century. Not a single individual who proposed the ether ever was able to tell you what the ether was. They could not make a picture of it. We don't have any pictures, right? Anyways, I asked him, what is a thing? And he said, a collection of disturbances. Absolutely cracked me up. So he's got a collection of verbs. Okay, we have all these verbs running around. And if you put a collection of them, put a lot of, runs and flies and swims together, you make an object, a thing, okay? I'll skip over the next two. He said, it says space is the ether universe. The whole universe is space. And ether is space, ether is universe, ether is everything. It's God, right? There's nothing outside of ether. It's continuous. It's a fluid. That's so far we understood nothing because he cannot draw it on the board, so we don't know what he's talking about. And he says motion. What is motion? The change. So I thought change involves motion. And it never dawned on him. So he just pulls these words out of nowhere and says, oh, motion is the change. Okay, and so the question is, how can the ether move? Because you're going to have, motion in the ether. How can the ether move if it is everything and it's not made of parts? So you have a single block of whatever with nothing outside of it. How does it move? It moves with respect to what? And so what these people do, they cheat, right? And they say, well, we have a location, which is a region of the ether, right? And that's the part that's going to wave or vibrate or whatever, and that's going to be light or an atom or electricity or whatever they think it is, okay? So this is the issue. The issue is they're going to choose a location within the ether, which is made out of a single piece, right? Nothing outside of it, right? And they're going to start moving something within it. That's where they commit the crime, okay? Ask them what is exist, important word in physics. And he says the ether is all that exists. He never defined the word. He just says that's all that is, whatever he means by that. What do you mean by exist? So he's saying ether is a synonym of exist, and exist is a synonym of ether. That's all he said. And yeah, when you look it up in the dictionary, you'll find out all these synonyms: existing, actual, real. And you can't use synonyms to define word, especially in a word so important a word as exist. What is a concept? It's an idea, he says, that exists, but not in reality. Man, it really cracked me up with all these definitions he had. But he says it's an idea, and you look up the word idea, what is it? It's a concept, a notion. And so all these words are synonyms. We can't use them at all. You see my definitions on the right. Okay, and so yeah, we have a problem with these people because they never define these words. They think that all this is word salad. It's just noise in their ears, and they don't understand why I'm asking these questions. For them, hey, I came here to do physics. Let me give my presentation, my theory. You can't even put your ether on the blackboard, or on the screen. What are you going to explain? I mean, we're explaining mechanisms. Mechanisms are mediated by things, by objects. You can't even define the word object, the word thing. You're saying it's a bunch of verbs. So we have the motion of verb. What are you going to put in on the board is for verbs? What are you going to put for, for all these shaking disturbances, as he called them, or vibrations, or whatever he's got in a tiny little brain? What are you going to put on the board? That's what I want to know. I don't want you to explain any of that. I just want you to put something on the board. I want to see something, okay, with my eyes. Okay, so what is the ether? Well, if you go back in time, you find proof, evidence. Here we have proof and evidence, so you better believe. Okay, here it is. We have here Rene Descartes and also Robert Boyle. What did they think about the ether, so that we can get at least a ballpark notion of what these people were talking about for hundreds of years. And according to Rene, ether, a subtle fluid substance that fills all of space and is comprised of tiny, constantly moving particles. So the ether was made of particles. Now we know. What did Robert Boyle think about the ether? He fooled around with air and a vacuum. I think it was Charles II. He came back after, Came back after his father's death. Can't remember the guy who took him out now. And he's the guy who essentially subsidized the so-called physicists. And then someone told him what Boyle was working on, and he says, I created this science group, and they're working on air. On air. Like, what the hell? And so, yeah, Robert Boyle worked on air, and he said a medium, what is the ether? A medium that permeated all of space, composed of what? Subtle particles, okay? And so these particles explain the absence of a perfect vacuum and the interaction between macroscopic bodies, including magnetism and gravity. Okay, so they had this notion that ether was just a bunch of particles. And just in case, here we have good old Newton. He writes a letter to Boyle, and he says, I suppose that diffused through all places in ethereal substance capable of contraction and dilatation, strongly elastic, and in a word, much like air. Right? And he goes on to describe essentially particles, bunch of particles, like air. What is air? A bunch of particles. Okay, and so he just says these particles of ether are just smaller. That's all he said. But they all thought of the same thing. The ether was a bunch of particles. That's what it's always been. That's the notion all these people had. No one specifically stated that, okay? Or some of them did, like Descartes, right? And Boyle. But a lot of people just went out there and they started using the ether. They went like these ethers do today. They just jump into the theory without telling us what the ether is. Like, well, it's the ether. Oh, okay, yeah. I know what the ether is. Yeah, sure. And so they just went and talked about their theories instead of telling us, look, this is the ether. Okay, so they never started there. And here you have 19th and 20th century. We have George Stokes, which was a prominent guy in Great Britain, physicist, right? And he said, ether, a medium composed of what? Particles. And Paul Dirac C, that's what he's famous for primarily, is a background medium comprised entirely of negative electrons. In other words, when you take all these electrons, you're thinking about a world of little particles, and they form this background, and all of matter is swimming within all these particles. And I like to say that it's more like a sandbox, what they're describing, because are they saying that all these little grains of sand are moving, or are they static and, the big players, the big matter moves within the sandbox? I mean, what are we talking about here? Anyways, today we have these two notions that you see at the bottom. Space is filled with what? Virtual particles that are constantly appearing and disappearing due to quantum fluctuations. So they have all this magic, which they say it's not magic. Quantum is not magic, please. They have all these particles popping in from the void and going back to where they came from, forming part of the space, I guess, right? Then you have this other notion, the energy notion, which is filled with seething energy. The quantum vacuum is not truly empty, but rather a dynamic sea of energy fluctuations. Whatever energy is, because energy is a concept, a mathematical concept. And so these people are talking about being filled with concepts. It's filled with love. That's what it is. Okay? Please understand. And go find out what shape love has. Maybe like hearts. I don't know. And yeah, so today we have these notions. Here's the field that we have today. Something looks like that. And that's what they have in the back of their minds. Of course, they don't even try to picture it. They just deal with it mathematically. They don't care about what it really means. They have no meaning. That's why when all these people come around and they say, oh, we can't find meaning in all this stuff. Yeah, you can't, because you're dealing with concepts. And, what are we staring at? What were those? Well, all that vibration that looked like a net, well, those are number lines. They're vibrating number lines, these people. So again, mathematics has nothing to do with physics, nothing at all. They'll never meet. One is a descriptive, quantitative discipline. The other one is an explanatory, qualitative discipline, physics. Okay, here you have the famous virtual particles. They come in and out from the void, right? And they form, I guess, part of space-time out there in the background. Okay, so I guess you've seen some of these. So, yeah, we have all these magical things going on. We have rabbits that appear from the void, then they go back into being holes, I guess. Gophers, and then they go back into their hole, and so on, I guess. They pop in and out. And, yeah, even relativity. Here you have, what is relativity? Well, space-time primarily, right? And space-time is what? A point in space. That's what an event is. It's defined as a point in space. There you have all the red points, and they make the net, the fish net that they put out there, the proverbial fish net. But yeah, they're made out of points, and what is point? Well, it's a grain of sand. So all of our universe is made out of grains of sand. What is a grain of sand in a box? Gazillions of them. It's known as the ether. So all these are ether theories. We've never abandoned the ether since the days of the Greeks. We've always had ether in mathematical physics, which is what we've been having for the last 400 years now. Okay, so what the ether look like through the ages? Well, always the same thing. Whether you talk about the Greeks, the Romans, or the 17th century or whatever, even to today, we have just a bunch of particles. That's what they've always put as a background. That's the only one they say. They discrete particles in the background. And so, is that what we have out there? Is that what our universe is? Just a bunch of particles that we can't see, and they're in the background. They pop in, become virtual particles, and go back because the mathematician needs that amount for something. And so he said, oh, the particle came in and I wasn't able to measure it because it just, blipped out of existence again. And so they have these explanations. Okay, so if you look up Google, what is the ether? Luminiferous ether. Well, here it is. Those are the pictures you'll see. And it says a hypothetical substance. Well, what is a substance? Are we talking about, made out of a single piece or made out of parts? And you can see the pictures are all made out of parts because you see all these arrows going downwards and they're all segmented. They're all made of dots. So they're suggesting that you've got this rain of particles just sweeping across the solar system. And that's what the notion that all these people had. So the notion of particles forming the ether has never changed. And so that's why I ask these people, these so-called ethers who believe so strongly in their hypothesis and their proposal, no problem. Show me the ether. Show me a picture of your ether. Either draw it, upload it, show me somewhere on the internet where you found it, show me the ether. That's how simple it is. You got the extraterrestrial, he comes and visits me, and I say, tree. And he said, what's a tree? I point, I say, that's a tree. Or I draw one, and I say, see, this is more or less what a tree looks like. So he gets an idea. House, here, house. Table, table. And I point. So he learns the nouns. Well, I want you to do the same thing with ether. Point to ether if it's a thing. And they say, well, there's nothing on the outside. I've never been on the outside of the ether looking at inwards. I can't see it from the inside because it's made out of a single piece. And they get through all this nonsense, but they never draw the ether. They never illustrate the freaking ether. Okay? So please illustrate the freaking ether once and for all. So since they don't do it, I do it. Here it is. There's the ether. That's what it is. That's what it's always been. A bunch of particles serving as a background. Okay, here are when they vibrate enough locally, then you have these waves. That's light, supposedly. That's what they always thought of it as, all these particles moving up and down in a wiggly manner. Okay, here's a single one, right? Here it is. Okay, that's more or less what the ether has been. A bunch of particles in the background, and what you see in the foreground, or, they're moving, is the wave of light. That's what it's always been. Then they, apparently, they decided that the ether does not exist, and so the question is whether is there something that underlies light? What is light? Is there something vibrating there? What is that something? And so they have this phrase that everybody just repeats without understanding what they're saying. They're saying, well, the wave doesn't need anything to travel through. And see, that means something different. It's like the fish doesn't need an ocean to travel through the ocean. It doesn't tell me anything about the fish. I'm talking about the fish, not about the ocean. And so the question is, if the fish vibrates, what is the fish? In this case, what is the analogy for light? If light does not need a medium like space, which is nothing to travel through, that's space. I want to know about the medium that underlies light itself. Okay, and that's a different question. And so these people always answer the wrong question. Well, what I'm not asking. Okay, so another thing that comes from these etherists, and they all say more or less the same thing because they all think in the same way. They all went to the same monastery, right? And this is what they say. They say, this fellow is saying that first, he talks about the thin ether vortex. So what do you mean a vortex? I thought ether was made out of a single piece, right? And there's nothing outside of it, and the inside is all one piece. So what vortex are you talking about? What's vortexing? What's vorticing? What's twisting? We have a tornado. Inside air, yeah, we can understand that. In fact, he uses air as an example. Yeah, air we can understand because air is made out of pieces, made out of atoms, right? So you're not saying that for the ether. You're saying it's made out of a single piece, but now suddenly you create a vortex inside the single piece ether? Yeah, because it's a fluid. Well, what is a fluid? Fluid is made out of parts, right? Then you can say that. But if the fluid is made out of single part, you cannot talk about a whirlybird inside, a single piece fluid. But I like the other one. He says, air and water are not physical objects. And just about everybody out there has the same notion. And this is an irrational notion. This is nonsense with what he said there, Ayn Rand also said that air and water are not physical objects. Yes, they are. Anything made out of atoms hopefully is a physical object. Why isn't it a physical object in their minds? Because it's like saying a smoke ring is an object. Yeah, a smoke ring is an object. It's made out of atoms, for your information. Anything made out of atoms, like a chair, a table, is a physical object. But they think that this one's a physical object because it's solid and I can sit on it, but air is not a physical object because it's constantly moving, it's changing its shape, so it can't be a physical object. So we have to stop the noise, the motion for these people so that they understand that, air is a physical object, so is water. Any fluid is a physical object. And the fact that you cannot see some of these objects does not mean they're not objects, because see and touch have nothing to do with the definition of the word object. That's one issue. But the other one is that motion is an issue of, so my table's not an object when I throw it across the room. Now it's not an object because it's moving. Can't I take a picture, a snapshot of that table going through, and at some point I take a snapshot and I got the table in a single frame of the film, right? Well, isn't that an object? Can't I say that's a table that's flying, right? But here in the picture it's standing still. And I can do the same thing with air and water. And here, let's prove it to these people. Here it is. Okay, so here you have air. You can see that bluish mist that's around the planet. That's called air. And I kind of outlined it there a little bit. See if you can see it, right? You see it there? There it is. Okay, you can see that's what I'm talking about, air. There, that's the air. Okay, so air does have shape. Okay, if we can take a snapshot of it. Okay, let's take a snapshot of it for these people because they still don't believe. Okay, give me a second here. Here it goes. Okay, I'm going to take a snapshot, okay? Here it is. Take a snapshot of the Earth, and you can see the air around it. It has the form of a shell. Now, this is a 2D picture, right? So it looks more like a donut, right? Or like, like a circle, or what is it? One circle inside another one, right? But let's get rid of the Earth so that these people don't get confused. There it is. Okay, that's what air looks like. It looks like a ring, looks like a donut. Actually, in 3D, it looks like a shell. Okay, so now you know what air looks like. Does air have shape? Yes, there you have it. Is shape a static concept? Yes, it is. And what I'm showing you is a static picture of air. Okay, so it's not moving there. And this bozo says, oh, but the electrons are moving inside your picture. The pixels are moving. Poor fellow. So what we do in those cases, we show them the universal movie, okay? And here it is, the universal movie. In the universal movie, single frame, there's no motion whatsoever. No electrons are moving in there. It's a cross-section of motion, a cross-section of time. It only has static concepts such as location, existence, and distance. And so only static concepts fit in a single frame of the universal movie. So once you have a single frame, we stop all motion. So nothing's moving in there. And in there, you can put anything you want. You can put air, you can put water, you can put whatever. It's a snapshot of water. Nothing moves there. If you want the electron to move, you want light to move, you got to have at least 2 frames of the universal movie. You cannot do it in one. Okay? And it's sometimes very hard for these people to understand what I'm talking about there. It just goes from one ear to the other. They're not even listening. Okay, here's a blob of water. Okay, astronaut releases it in space. Okay, so he popped the balloon, and here's the blob of water. He color-coded it a little bit so you could see it. Okay, and what does he do next? Well, he's going to take a snapshot of it. There it is. Okay, so we have it in a single frame of the universal movie. Okay, God's camera. Okay, so does that have shape? Yes or no? So there you have, water does have shape. And people say, well, what's the shape of water? Wrong question. The answer is, the question is, does it have shape? It's a yes or no type of question. It's not a what is the shape of, you know. And the question is like for what field or for energy, does energy have shape? Does love have shape? Does intelligence have shape? And the answer is no, because those are concepts. So you got to choose if it's a concept or an object. All words in the dictionary fall under one category or the other. There are no other types of words other than concepts and objects. There's no other category, except in the religion of math and philosophy. I'm talking about science, okay, here. And in science, we only have two categories of words. Either they have shape or they don't. And that's not the definition of concept, but that's a good way of detecting if a word belongs to objects or to concepts. You know, it doesn't have shape, concept, automatically. Okay, anyways, for the etherists, the homework is draw the damn thing. I want to see the ether on the board. What you're going to do your motions with. I need to see a picture. Don't explain it. Don't define it. Define it if it's a concept, but then you can't use it as an object. But if you're going to use the ether as an object, first step, picture. You need a picture. You need an image. We need to see what the ether is. Okay? Straightforward. Okay, let's get to the main course today. Long introduction, but I had to go through all that. And partly involves the subject matter that I'm going to touch upon next. You know, we had light. We've known about light for hundreds of years. I mean, people have asked questions about it. Al Hazen over there in the Arab world, you know, he worked on light, and so did a lot of his friends out there. You know, they worked on light, and they tried to figure it out. And in the 17th century, 1665 primarily, Robert Hooke, you know, he's the first one who noticed that light had these wavy things. He said, oh, it looks like a wave, like water waves. He was looking through the microscope at some of the things that he was going to draw, because they didn't have snapshots in those days. They couldn't take a picture. But he drew them, and he put them in this book called Micrographia. And he's the first one who proposed the wave theory of light, that, you know, that apparently light had some wave characteristics. And later on, Huygens and others worked on it further. And what's the issue? The issue is here, it's been 400 years since then. Do these people, these mathematical physicists who, you know, have these great men of science as you know, their precursors, do they have any idea what light is today? And the answer, well, let's find out what the answer is. Let's see if these people can tell us what light is. Here's one fellow, and his name is Arvin Ash. And what Arvin tells us is that, you know, light apparently goes in one direction. It's made out of particles. This is the notion, because he's talking about bouncing. So listen to him. Don't listen to me. Listen to him. He's going to tell you that light is made out of particles because it bounces. It goes forwards and bounces. Here it is.
Look around the room that you're in. What you're seeing is not matter. You can't really see matter. What you're seeing is the light bouncing off that matter that enters your eyes, that your brain then interprets as matter, as objects. So you're not seeing the objects themselves, but the light bouncing off of it.
Okay, we have to think of particles hitting the guy's eyes and bouncing off. I mean, that's what he seems to be describing or explaining, right? So now we know light, according to at least this gentleman, are particles that hit the eye and bounce. Okay, so that's what you receive every second of the day. But here we have another fellow, and his name is Derek Muller, and he's going to give us something similar. He's going to say how light originates. It originates in the quantum jump. Okay, you have this electron bead going between orbitals, between energy levels. When it comes down, it releases energy. Okay, that's the part he's going to explain. Another fellow is going to explain the other side of that coin, and here it is. Listen to him. Here it is.
It has a positive charge in the center and negative electrons whizzing around it. Why don't they just spiral into the nucleus, radiating their energy as they go?
Yeah, why don't they answer that question? I mean, they had that question for 100 years. Why doesn't the electron spiral to the nucleus? One is negative, the other one's positive. They attract each other. Positive attracts negative. There should be a collision in the nucleus. That doesn't happen according to their atom, right? In their version of the atom. So they never explained that. That was the reason quantum was started 100 years ago, and here we are 100 years later, and we still don't have an answer from the mathematical establishment to that question. Now, here's another fellow. His name is Matt O'Dowd, and he's going to give you the other version when light comes into the atom. Okay, listen to him. Here goes.
Normally, if you radiate a bunch of atoms or molecules with a bunch of photons, each might absorb a photon, bumping an electron to a higher energy level, and then radiate another photon as the electron loses that energy.
Okay, so we're all on board. We have this electron bead. Negative electron bead goes around. For some reason, it doesn't fall to the nucleus. They're still investigating that after 100 years, but we cannot explain why it spontaneously doesn't fly away either. We don't have a physical interpretation for that. They can probably explain it with words such as energy, meaning they don't have an explanation. They just have a mathematical description, but we don't have an explanation for why. What causes the electron bead not to fall or to fly away? Both those sides. And after all is said and done, we have another fellow, and his name is Nick Lucid, and he has a show on YouTube, and he says the electron doesn't orbit. Okay, you what? I thought these guys go to the same school and they come up with different ideas, and the question is who's right. Here it is. Listen to him.
The idea of electrons orbiting in atoms is totally ridiculous. The electrons would continuously lose energy until the atom collapsed.
Okay, now who's right? Which quantum version should you accept? Should you accept the one Matt Dowd and Derek Muller proposed, that there's an electron bead going around the nucleus? Or should we go with the one that Nick Lucid proposes, says, no, the electron doesn't go around, because otherwise it would fall into the nucleus. So they all tell you what it ain't. No one tells you what is. I need to know what is then. But see, they never give you an explanation. And here you go through high school and college, and you never get an explanation to how the atom works. They still don't have the slightest clue. And obviously, because they've got the wrong model. They have the bead model, the particle model, which should have been discarded 100 years ago. You can't do physics with discrete particles. You can't do gravity, you can't do entanglement with discrete particles. Assuming you use those as mediators, you still can't affect the guy on the other side, much less instantaneously, So, yeah, it's a big problem. And here you have, again, is this what they're invoking? Are they invoking the planetary model? Okay. And yeah, this is what they're invoking. And so they use this model, but it's a ridiculous model because they cannot explain, why the electron doesn't fall or fly away spontaneously. But that's the one they use, and that's the one they're going to explain quantum jump. They're going to explain ionization. They're going to explain electricity, all with that model. So the model is ridiculous, it's irrational, but that's the one they use for explanations. And then they tell you, well, that's not our atom. Okay, show me the real atom then. Okay, just in case, Derek comes back and he tells us that, the light not only has wave nature, but matter has wave nature as well. And here it is, listen to him.
If light could be both a wave and a particle, then maybe matter particles could also be waves.
Okay, so now it's matter can also have wave properties. We all wave. So they have all these wavy notions. We have Mr. Nick Lucid again, but he comes back and he says, hey, I can tell you exactly what light is. Okay, finally, someone who has the nerve, the balls, to tell us what light is. Here it is. Listen to him.
Light? What is it exactly? Light isn't a wave in matter. It's an electromagnetic wave. Light is made of particles. We call the particles of light photons. So which is it, waves or particles? Both. Those things that you always hear being called particles actually display properties of both. They're particle waves.
So now you know it's particle waves, wave particles, duality, complementarity. That's what it is. So they use both. They say it's both. They covered all the bases so that you can't criticize them. They say it's both a particle and it's also a wave. And Niels Bohr said, the experiment is the one that pulls out which of the two this thing is going to collapse to, right? And just in case we have Mr. Arvin Ash, and he's going to tell us that light doesn't really travel. It's not photons. It's not waves. What travels is information. So let's see what good old Ash has to say here. This is what they learned by rote. Here, listen to him.
All the information that you have is carried by tiny quantum objects that make up that light called photons. And this information is traveling at the speed of light.
Okay, so now you know it's not light that travels, not photons that travel. What travels is information. They have all these concepts traveling through the air. Intelligence goes in that direction. Love goes in that direction. Information always goes straight, so watch out. You got to duck because all these concepts are flying around. Anyways, here we have good old Mr. Penrose. He's a Nobel Prize winner. Hey, you got to listen to him, right? Okay, so here it is, and he's going to tell you something about the wave function collapse. What is that? When the wave hits a wall, it's like a fart. It hits the wall, it turns into shit. Well, this is more or less the same thing. You have the wave, it hits something and turns into a ball. And he says consciousness is not what collapses the wave function. What collapses the wave function is what? Physics, meaning a physical entity, some physical object. So there is something in physics which collapses the wave function. The Schrodinger equation, quantum theory as a whole, is wrong. Whoa. Oh man, he can say that after he wins a Nobel Prize, not before. Otherwise he'd never make it there. Quantum mechanics is wrong. Jesus Christ, those are strong words. Einstein and Schrodinger said it was incomplete. Okay, incomplete means wrong. Yeah, he can say that because he's a macho man. He's up there now. He's got his Nobel, and he's 90 years old, so he doesn't care anymore. But he couldn't have said that 50 years ago, before he was somebody, If he would have said it then, that would have been the end of his career. But now he can get away with it. And that's what they do. When they're young, they all vouch for quantum mechanics and relativity. When they're old, they say, well, I didn't understand squat all these 50 years, and I think it's garbage. And that's what I'm saying now. I'm saying it's all garbage, okay? Please understand. Okay, there's one fellow out there, he says he can bend light. And the question again, are we going to bend light, or are we going to deflect the photons? Are we going to deviate them from their path? Right? Those are two different concepts. I mean, if light is made out of photons or even out of one-way waves, moving like in that direction, right? And then suddenly it turns a corner, well, then you can't say it bent. What's bending? A wave is bent? No, you can say the wave was deflected, or the photon, the particle was deflected, but not bent. But these people talk about the bending of light. And they all talk the same way, and here it is. Listen to him, and he's going to show you how he bends light also. Okay, here it is.
I'm going to be showing you a crazy cool experiment that just shows you how to bend light.
So can we bend light? It would appear like that's the case, right? But see, if every atom is connected to every other atom, and there's gazillions of atoms in just, a cubic centimeter, gazillions of them in there, right? And every atom is connected to another one, you cannot say that light was bent, right? And curved. No, from one atom to another, it's straight. From that atom to another atom, it's straight. But if you take all those, then for our macro world with our eyes, right, it looks like a curve. And here, let me show you what I'm talking about. Here you see some patterns that are made, curved patterns that are made all with straight lines. So you don't need to bend anything. In other words, light doesn't have to bend. You can make, curved surfaces or curved patterns with straight lines. And there you see it. And that's exactly what light does. Light goes from one atom to another atom in a straight line, right? We can say straight line here. They're taut. The ropes are taut. Okay, that's what we're proposing here, that all atoms are interconnected by elongated ropes. And from one atom to another atom, the light travels straight because it's a torsion of a taut medium. That's why it can't get lost. It can't curve or anything like that. It's always it's torquing in place in situ, okay, between any two atoms. But atoms are close by together, so if you put a gazillions of them, you say, well, light curved. No, light did not curve. What happened was from one atom to the other, it was straight, but there's so many atoms so close together that for our macro world, it looks like a curve. That's all it is. And here's what we're proposing. Again, we have two atoms bound by a taut rope. And both those atoms are connected to every atom in the universe, again, by taut mediators that have the appearance of a rope. That's why we propose the rope model. Okay? We're saying between any two atoms, like if my fists are atoms, so this is always tight. That's what it is. And what you have is torsion. Okay, that's what it is. That's why light travels so fast, because it is a torsion of a medium that's already in place. It doesn't have to travel. These people think that, a photon goes from A to B. No, there's no A to B. What is moving, you can say, the signal that's propagating along the rope, what it is essentially the torsion of the rope itself that already gets a signal at the other end. That's why light is so fast. And with a physical object, you can explain that. In fact, I always suggest that people will take, you take your grandmother's clothesline, put it tight between 2 points, as tight as you possibly can get it, tighten it up. And just put two clothespins, like I did. And you move one and the other one moves instantaneously. You film it, you'll see it. Do the experiment or the observation. You'll prove it to yourself. You don't come here to believe, we come here to explain. There's the explanation. You want to do it, go ahead and do it. Okay, and where did I get this notion that, all atoms are interconnected? Well, here you have, again, Richard Muller. He's from Berkeley University, and this is what he's got to say. He says, every atom on Earth is pulling on every atom of you. You are also pulling on it. So how do you pull unless you have something like this, some elongated mediator between two atoms that are pulling on each other? Okay, so, unless you do black magic and say, look, one atom's pulling on the other one, but there's no mediator. Yeah, tell me about it. Then you're not doing physics. Now you're doing Alice in Wonderland, So he's saying every atom on Earth is pulling on every atom of you. You're also pulling on it. You're pulling on atoms right now on the other side of the Earth. So this atom here is pulling on an atom that's on the other side of the Earth, and it says gravity goes through things. So it goes right through the Earth to the other atom on the other side of the Earth. Now, you should stop and think about that for a second, because you can't explain that with relativity. You can't explain that with general relativity. You cannot explain it with space-time. And how is quantum mechanics going to explain it? Well, with negative momentum transfer or some nonsense like that, so Yukawa potential or whatever, they have to go into math. They can't do it physically. They cannot show you in the lab how that happened. I can show you here in the lab. Here's the lab, okay? I can show you why. This one pulls on that one only if there's an elongated mediator. You don't like the rope, you'd rather have, Here's a thread. If I can get it here. Here's a thread, okay? Hey, there you go. Okay? That's more or less what we're talking about. Of course, this is extremely thick compared to what the rope is in reality. But now you can see why this finger can pull on that hand, because they're connected by something. But how do I pull? How do I pull with nothing in between? You got to put something in there. And so mathematicians say, well, I can't see anything, I can't touch anything, so there's nothing there. An object is not that which you can see or touch. An object is that which has shape. There's something here that has shape that I cannot see or touch. That's their logical conclusion. And never occurred to them that, something like that could be our real world. And that's the issue. The issue is that they have never identified the invisible, intangible objects that have shape that Mother Nature and Father Universe use to do their daily work. With that, I'll see you next week. Bye-bye.